All right, well, thanks everybody. Thanks for the invite to present. For those of you who haven't been following Volt, I want to give you kind of a little intro, and feel free to stop me if I figure when using Google Hangouts, the fan's going to kick in here in a minute. So if it gets hard to hear me or something, let me know. Or if you have questions, feel free to stop me. Um, Uh, for those of you who don't know me or who haven't, Googled me or something, my name's Ryan Stout. If you do Google me, you actually won't find anything on me because there's a comedian named Ryan Stout, and but fortunately, I have at Ryan Stout on Twitter. So whenever about twice a day, I actually get tweets from random people I don't know telling me how funny I am, which obviously doesn't help my doesn't help me when making presentations. So if I make jokes that aren't funny, feel free to let me know. um, what I want to talk about though is complexity in web development. That's kind of the problem that Volt is trying to help eliminate. I've been building web apps since about '96, back when it was CGI and Perl, and I kind of noticed this pattern with web development where frameworks and tools, we kind of keep adding things on as new technologies come around and new techniques. And it kind of, the overall complexity, I think, just kind of goes up and up and up until someone kind of, and usually a bunch of people try to do it at the same time where they'll kind of stop and then try to kind of solve the problems of complexity all at once. And I like to think of it kind of like packing a suitcase. You kind of keep stuffing things in until eventually you realize you didn't do it right. Or not that you didn't do it right, but now you have a lot more stuff than you originally anticipated. And so you have to go and kind of dump the suitcase out and start over. And so I think there's a lot of people right now trying to solve that problem so that we can kind of get back to a lower complexity for building web apps. And kind of just so you get a feel of what I'm talking about, I think 2004 and shortly after was kind of a low point for complexity, which is good. So you had Rails, for example, came out, and for the previous 10 years in web development, we'd basically been learning how to output HTML, and there were a lot of things that kind of added to the complexity of outputting HTML, but Rails was able to kind of take all of that and give you a good structure and move a lot of that complexity into the framework. So at around 2004, I was developing Java web apps professionally, and when I saw Rails, it really made me realize kind of how much duplication and complexity we had in our app, because Rails was able to really structure it so that you could get rid of a lot of that. But kind of moving forward from 2004, in 2004, Gmail came out, and so the next year, Ajax was kind of the big buzzword, and so we started doing a lot of what we were calling Ajax back then, which was really just a little bit of front-end JavaScript and basically rendering views to the front end, or rendering views and then sending that to the client. And then in 2006, for example, we started. I think the Rails team was kind of had the foresight to know that we were going to be sending a lot of data to the client, and so they standardized kind of on REST and JavaScript as a way to ship that data, raw data, to the client, which I think was smart. And so we started basically just having a lot more front-end JavaScript, and 2007 kind of continues. And then in 2009, we're basically shipping, at least for me, I was shipping so much JavaScript to the client that I think the Rails team kind of saw that we needed a way to easily implement the best practices, so minification, concatenation, things like that. And so they added the asset pipeline, which solved a lot of problems, but again, adding more complexity. And then around 2011, a lot of these front-end frameworks started to get popular, so Ember and Knockout was popular at the time. And so at this point, we start basically building full MVC apps on our client as well, and we're still syncing data with Ajax and REST. And then in 2012, now there's a lot of sort of front-end JavaScript, little front-end JavaScript libraries for different things. And so Bower, for example, comes out, and that kind of helps with the asset loading. And then it wasn't really until even last year that routing in a lot of these frameworks on the front end got good. So I started using a lot of front end routing in 2013, and having the browser history API kind of helped with that. And so in 2014, this is basically where we are. We've got a lot of complexity, and we can kind of look back at 2004 longingly. um, but we're doing a lot more, so it's not all a trade-off. But I think as web developers, we kind of, at least for me, I kind of come into work and it's this kind of sea of complexity, and I kind of feel trapped as a little bit. And I think especially for people um, who are coming in as as desktop developers and things, they kind of think this is a little bit crazy. If we look at the complexity chart, they kind of think, especially coming from desktop development, where a lot of this is pushed into the frameworks. This seems really crazy to be doing all this duplication. And so I think Volt and a lot of other frameworks right now are trying to solve this problem and trying to see how can we improve things. So what's the solution? Turbolinks, obviously. No, I'm just kidding. And no offense to if anyone worked on Turbolinks or anything. But I think the solution is isomorphic app development. So hang on one sec. Sorry. Okay. So isomorphic is a math term that means similar in form. If you want to get a buzzword popular, you can't go wrong with taking a math word and reusing it, because they have a lot of really good sounding words that people don't know what they mean. So the tech community's kind of repurposed isomorphic to mean sharing code between the client and the server. So if we look at the complexity chart, it's pretty easy, I think, to see what needs to happen. We need to find a way to stop all the duplication. So we need a way to sort of merge so that we're only writing models, views, and controllers once, and routes. And then once we've done that and we have our models on both sides, ideally we can replace REST with sort of auto-syncing. So if you have a model on your client and your server, then you can basically update your model, and your model would, say you change your model on your client, then your model can automatically change the model on the server with something like WebSockets or some of those other fallbacks. So I'm going to call this auto-syncing, which is kind of, instead of manually handling syncing state between the client and the server, we just have the framework do it automatically. And then ideally, we'd want to unify our asset packaging. So again, isomorphic is sharing code between the client and the server. And for those of you who haven't heard of Volt, Volt is an isomorphic web framework for Ruby. And so you might be wondering, how can you build an isomorphic framework in anything but JavaScript? You would think, JavaScript is the language of the browser, so if we want to build an isomorphic framework, we have to build it in JavaScript. But Volt actually uses, there's a great project called Opal, which is a Ruby to JavaScript compiler. And I'm going to talk about it a little bit more in a minute, but basically it lets you write mostly normal Ruby code and have it run in the browser or anywhere that JavaScript runs. So what Volt gives you is it lets you share controllers, models, views, and routes between the client and the server. So you can write the same code and have it run on the client and the server. I'm really excited about this, so I thought I'd make it really large. It gives you reactive bindings for the DOM. So this is similar to something you'd get from Ember or Angular, where you can change your model data and the views will automatically update. I'll show you our views in a little bit. They're basically just Ruby code inside of mustache tags. It also gives you the automatic data syncing that I talked about. So I'll show this a little bit more in a minute, but basically we can change our models and things automatically sync back to the server, and then we use WebSockets to sync to any other clients that are listening. And there's permissions and things that can be in place, but kind of by default things automatically sync to anyone listening. And then the other thing that Volt gives you is you build your apps as nested components. So a one of the things I noticed building web apps for a while is that we all kind of start out thinking, okay, I might reuse this part. When time comes to reuse it, I'm going to go ahead and pull it out, put it in a gem or a Rails engine or something like that, and reuse it. But what happens is when we start to do that, there's a lot of kind of coupling that we need to figure out in order to actually pull it out into a separate component. And so the way Volt tries to solve this problem is to make everything sort of initially built as these nested components. And then when you do need to pull it out, it's sort of already isolated and siloed. And so it's really easy. We kind of have one command that you can use to basically pull part of your app out and put it into a gem. I want to talk a little bit more about Opal for those of you who haven't used it. There's sort of this perception, I think, that compiling to JavaScript is going to add a lot of complexity to my project. And so here's kind of, I think, how people expect things to be. So they sort of think on the left you have JavaScript, and there's sort of the complexity of JavaScript as a base language, and then JavaScript has all this extra complexity because it was a language that was built in 10 days and sort of rushed to standard. And so it's got a lot of things in the language itself that sort of make developing big apps hard. So you've got, this has all sorts of problems. You have type coercion. There's no standard library. And then there's kind of this whole category of what I call WTFs, or what a lot of people call WTFs, where things just don't behave like anyone would expect them to. And then there's the falsiness is kind of strange in JavaScript, I think. But then people sort of expect, okay, well, there's those problems, but they expect that compiling a language to JavaScript is going to have all these extra problems. So they expect that, there's going to be all this debugging complexity, and the file size generated is going to be really huge, and they expect the performance to be bad, and they expect sort of bridging and calling JavaScript from the compiled language is going to be complicated. So what I'd like to show is that the Opal team has done an amazing job, and I'd like to show that it actually looks more like this. I will concede there's a little bit more debugging complexity. I think I can show it's not actually too bad, and that the other things are basically non-issues. So this is a slide from talk from Douglas Crockford. He's kind of one of the big names in the JavaScript community. He wrote the Good Parts book. And here he says, I stopped using new years ago, I stopped using object create, I stopped using this, I stopped using null, and I stopped using falsiness. And part of me wonders, one, what does this code look like at this point? And then two, if there's so many things kind of fundamentally broken in JavaScript, we can obviously avoid those things, but it makes kind of compiling to JavaScript even more appealing, right? So there's kind of, it's not just that we want to use a different language, it's that there's all these things that we can avoid if we use a different language. So JavaScript has, again, all the WTFs, and I think this is the thing that really makes it difficult, is things just aren't, they're semantically broken. So something like CoffeeScript fixes some of the syntax difficulties but doesn't fix the semantics. So that's why I think picking another language that's well established like Ruby really makes a lot of sense here. And talking a little bit about the perception, I think everyone, for whatever reason, they expect JavaScript to work, and in a lot of ways it doesn't, but then they expect compiling to JavaScript not to work, and it does. So here's a quote from someone. They said, experimenting with Opal, every time I expected to find an issue, nothing happened. Maybe it'll be time to retire CoffeeScript soon. So I think this speaks to the perception of, we're so used to dealing with JavaScript's warts by hand that we think if we're compiling to JavaScript, we're still going to have to deal with those complexities, and we'll have to deal with the complexity of compiling. But that's not actually the case. One of the things that's neat about compiling one language to another is that it lets us amortize that complexity into the compiler. So for example, if I'm writing C code, I don't have to know which register an instruction will work on. All of that complexity is pushed into the compiler, and as a C developer, I can just write C code. And so I think a lot of languages right now are starting to compile JavaScript, and I think it's because we're kind of coming around to this and understanding that those compilers can actually handle all of the complexities of JavaScript in the compiler itself. Talking about file size, that's another common concern. Here's the uncompressed minified and minified deflate sizes. I'm just going to jump to minify deflate because that's kind of really what we care about as web developers. As you can see, Opal and Volt, so this is Opal has a small runtime library. It's really small. And then this is all of Volt, which is fairly, like we have most of the features that Ember and Angular have, and we have a full data layer, which Ember doesn't ship with, and a full router, which you don't get with Angular. And so Opal and Volt basically sit in between. And so this is after the code's compiled through Opal. So you can see where the Opal doesn't actually end up adding a lot of files, or doesn't actually end up adding a lot of file size. And then the other big concern people worry about is debugging in Opal. So I want to walk through why debugging in Opal is actually a pretty nice experience. The first big one is that Opal is not compiled in the sense of, you know, a lot of the early language to JavaScript compilers they would basically compile to a bytecode and then ship a small virtual machine to JavaScript, and this made debugging really hard. But what Opal does is it does what's called transpiling, which means it tries to map concepts from Ruby to JavaScript. So, for example, local variables just map to local variables, instance variables map to object properties, methods map to object properties with a $sign prefix, and then classes map to prototypes. And there's a little bit of extra code to handle things like super and things like that. So if we look, hopefully you guys can see this. You can say something if you can't. But so this is some Ruby code that I just wanted to show what it looks like after it's transpiled. So here you have a class that takes name and age, computes a birth year, and then returns a welcome message with the birth year. And so if we look at the transpiled code, here's basically the class body. You can see that first it's setting up the name property and the birth year. And I should say def is actually set to the class's prototype. So it's setting name and birth year to nil. And then this is what the initialize function looks like. So it's assigning $sign initialize on the prototype, passing name and age. And I think this is all pretty clear. The only thing that's a little strange, I guess, is scope.get is the constant lookup in Opal. And then the $sign minus is the subtract as a method call. And then, you know, here's the welcome message, and it's just string concatenation. And then the and welcome message is because methods in Opal or methods in Ruby return their name as a symbol. And one thing that is a little different is Opal doesn't do, it only does strings and symbols are the same thing. So just that's one thing to keep in mind, but that's sort of doesn't end up actually being much of an issue. So here's some Ruby code, and then below it is the compiled JavaScript code. I think it's pretty easy to see kind of why debugging is easy, but obviously we can do better than that. So Opal comes with source maps, which basically lets you, in Chrome and Firefox, you can actually see kind of all the compiled Ruby all the Ruby files in addition to the JavaScript files. So what that lets you do is when you get a stack trace or something like that, you can actually jump into the Ruby code and it maps the lines between the JavaScript and the Ruby code. So when you get a stack trace, you can actually just jump straight into your Ruby code and start working on it from there, which makes debugging really easy. And then in addition to that, the browsers now have a thing called framework blackboxing, which lets you say that part of your JavaScript code is a framework. So for example, you might say, okay, don't show me anything inside of jQuery because I know jQuery works. And so when you're doing that, if you black box something, it won't show up in stack traces and it won't show up when you're stepping through with the debugger. So in our case, we would black box Volt and Opal so that none of the framework code or the Opal, like the Opal methods, show up in stack traces. And so if you combine all these things, you get nice sort of Ruby-esque stack traces where you can jump into your Ruby code. So it actually makes debugging a really great experience. One of the other things that's helpful is there's a project called Copenhagen.rb, which gives you Opal in the browser. And this is actually runs the full compiler in the browser, and you can run any Ruby code, and it's got a little terminal that you can use and things like that. So that's really nice. And then I think the last reason why debugging in Opal is actually really great is that Opal runs against Ruby spec, They obviously don't pass all the Ruby specs, but they pass a lot of the ones that aren't, file specific and things like that, things that don't make sense in the browser. And so, because they're running against Ruby spec, you can kind of know that it's a faithful Ruby implementation. And what that means is, for me at least, when I'm developing with Volt, I will actually run my specs in both MRI and Opal. And so it's neat because 99% of the time when I get an error in one in MRI or Opal, I'll get it in the other. And so what that means is then I have access to all of the MRI tools to debug, to help me debug. Performance is another concern. I just kind of threw this together really quickly. Here's kind of a sense of some of the things. I think you can see because of the transpiling, there's not actually a lot of overhead. The last one I want to show is interesting actually because JSON.stringify in, I actually got these. Sorry, I actually just realized I got the bars are wrong. Oh no, they're not. Sorry. Sorry. Actually, yeah, they are. The taller one should be the Opal. Let's see. Oh, sorry. I just have it backwards. Okay, sorry. It's early over here, so. So on the JSON.stringify, that's actually running C code in most of the browsers to stringify the JSON. And then toJSON is actually running an Opal and calls toJSON all the way down. So I think that's actually nice because you can see that even doing a lot more method invocation and sort of walking the entire tree in JavaScript, transpiled JavaScript, it's still pretty quick. So I think that's kind of neat to see that the performance doesn't take a major hit. Obviously, you can't access the something in native C like JSON stringify, but it's still relatively fast. And then the only thing Opal still is kind of a little slow at is math. So if you're doing a ton of heavy math, I'd recommend you drop down to JavaScript. And you can do that actually anywhere in Opal. You can use backticks to write inline JavaScript. And again, because locals and instance variables are the same, you can access those in that code. So hopefully you can see that Opal, instead of providing kind of this expected complexity, you actually end up with something like this. And I think, I think if the complexity did look like this, I don't think it would make sense to compile to JavaScript. I think really the JavaScript warts and problems are issues, but I think it does need to be a pretty big win in order for that to make sense. And so I think really compiling Ruby to JavaScript is actually a pretty big win for overall complexity. So let me talk a little bit about Volt real quick. I've been talking about Opal. Volt gives you a bunch of different things. One of the things we give you is what we call collections. And these are basically different places that you can persist data. And so they all have kind of the same API where you can sort of store hashes and nested arrays. But they end up persisting in different places. So page, for example, is a temporary store on the page. Store syncs to the database and other clients. Params is the URL parameters, and you can use routes to map those parts of that into the URL. Local store is the local storage. Cookies is cookies, and we have a bunch of other ones that we're working on. And so one thing to keep in mind with Volt is that where Rails is kind of a traditional MVC framework for the web, you have, a request comes into your controller, the controller goes to the model and gets the data, brings that model back to the controller, and then that data gets set into instance variables, which get passed to the view, and then everything renders, right? So this is kind of how Rails does it. Volt is more, because it's also a front-end framework, we use the MVVM pattern, so this is model, view, view, model. We actually call our view model a controller, which you'll see in other places. So it's a little confusing, but I think the term view model is just really it's not a very good term for what it does. I get that they're trying to say that it's between the view and the model, but we ended up going with controller. So when you hear controller in Volt, you can think view model. And what's different here is that on the front end, the view and the controller and the model stick around during the entire life cycle of the app. So at any point, the view can say, hey, something changed. Can you get me the new data? And so we have to keep all that around. And so basically in Volt, things start with the view. And so it will start going down through the view, and anytime it hits a binding, the value in those bindings are actually method calls to the controller. So say we hit a binding that asks for some data. it's going to hit the controller, and the controller can either, if it has that method, it'll respond to it, and if it doesn't, it can pass it down to the model through method missing, for example, and then the model can respond to it, and it'll get passed all the way up. So I'll show you kind of an example of that here in a minute. Okay, let me just jump in. I'm going to do a real quick demo here. So over here is this is basically a blank app that you get with Volt. And over here is the app, and then over here is the code. And so Volt, again, since it's built in a series of components, you get one component by default, and that's this main component. And inside of that, we have kind of traditional things that you'd see in Rails. You know, you have assets, config, controllers, models, views. And then, so in our views, I'm going to go ahead and jump into the index view. And I'm going to just do a real quick to-dos example here. And whenever I hit save, things automatically reload over here. So that makes it easy. And then what I'm going to do is I'm going to go ahead and create a form that helps us add a to-do. So I'm not going to explain all the details of this. I just kind of want to give an overview and kind of give you a feel for what it's like to work in Volt. These E- attributes basically bind events in Volt. So we're going to say whenever the form submits, call add to do on the controller. And so here I can go ahead and make an add to do method, and then we'll go back to our view and we'll go ahead and add an input. Let's see. For our to do. So let's see. I can get rid of this. So what we're going to do is these are our bindings. It's any Ruby code inside of a double stash. And I'm going to just bind to new to-do on the page collection and then to a label. The underscores, if you haven't seen Volt, are sort of a prototyping tool. You may not actually use this in production, but it basically lets you use fields before you define them, or attributes before you define them. So if you use the underscore, you can kind of access things without setting up the field manually. So it's really nice for prototyping. So once that's bound, I'm going to go ahead and go into my controller, and I'm going to say that the model for this controller is page, which is the temporary store. And then whenever they add a to-do, I'm going to take that new to-do and append it to the page to-dos collection. And then I'm going to set new to-do back to empty. And then the last thing I need to do is actually just show. I'm going to show the to-dos in a table. So I'm going to loop through them with the Ruby binding, and then I'm going to say to-do.label. Save, reloads over here, and now we can type to-dos, and they automatically add over here with very little code on my part. Really, I just bound the values, and then whenever the add to-do got called, I appended it. So that's pretty simple. One of the other things, obviously, it's not a to-do until you have a checkbox. So let's do a checkbox, and then we can bind the checked value to to-do.complete. And let me grab some CSS code here. Let's see. Sorry, one second. So I'm going to grab CSS from another project here real quick for this. And I'm going to put that in my assets, CSS, and then my app, CSS. And Volt will automatically, by default, load all of your assets. You can there's ways to specify to be specific about load order and things like that, but by default, anything in here just gets auto-loaded. And so what I'm going to do is, what I want the label to strike through whenever the box is checked. So I can go ahead and make the class conditional. So I'm going to say if to-do is complete, then show the completed class, I think. Let me see real quick. It must be complete. Hang on. Okay. Okay. And so now, basically, whenever the state of to-do complete changes, we're going to have the class show or hide. And so this is kind of showing the reactive bindings that Volt gives you, where it knows that you access this data in this binding, And so whenever that data changes on that collection, it knows to automatically rerun the view and update it. And then real quick, obviously we want a delete button, so we can just say, put an X in there. We can just put this in the view for now. You wouldn't normally do this, but and that gives us a delete button. And then let's see what else. So let me show one other thing real quick. So right now we've been using the page collection, but again, there's a bunch of collections that we can use. So we can use the store collection, for example, and this will persist to the database. So when it refreshes, there wasn't anything in there. But if I enter a couple of these and then I reload, it's persisted to the database. And then what's neat is actually if I bring up another browser window, it's going to actually sync back and forth between any of the clients that are listening. And so this is using WebSockets and basically pushing the data out to the clients and syncing the entire app state. So I didn't have to build any of this. It basically just comes for free as soon as you start using the store collection. And so it's nice because since all the collections have the same API, I can easily sort of switch back and forth between things. So let me show one other last thing. So what you might want to do is have it where you can select one of these and then show some extra information below it. And so the way I would do that is I'd bind a click event to the TD, and I'd say whenever it's clicked, let's set params, which is the URL parameters, to the current index. And then so when I save and I do that, you can see up here it's basically setting it to the current index. And then we want to show which one's selected, so we'll do the conditional class again. So we'll say if, and I'm going to go ahead and go into my controller and make a current index method that returns the index on page, and then I've got this OR syntax. So this is sort of like using double pipe, but it handles a couple extra things, and then I'll convert it to an integer. So so in here I can say if current index equals index show selected, and then that lets us basically toggle through the selected ones. And then back in the controller, I'm going to make a current to-do method, which is going to look up in the to-dos the current index, and the bindings will work through any kind of level of methods. So here we're going to go ahead and say if there is a current to-do, so if it's not null or nil or something, let's show its label, and then let's actually do a text area that we bind to a description attribute. And so now what this gives us, let's see. Sorry, one second. Oh, and so now what this gives us is we can see whichever one's selected, and then we can input some attributes, some notes about it, and that'll stick with it. So that's that would be a lot of code, I think, in a lot of other frameworks. Obviously, some of the front-end frameworks help you, but having Ruby kind of in the bindings, I think, makes it really, really concise and still pretty easy to understand. One last thing that we might want to do is actually validate this form input. So in Volt, we can actually create models. So we can say, I have. Sorry, I should use the generator for this. And then we can say, let's validate the label, make sure the length is at least 5. And what we're going to do is we're going to add there's a component gem that Volt has called Volt Fields, and that basically lets you, I'm going to bundle here. It will kind of provide a nice UI to show the validations. So the other thing we have to do is say that our main component depends on it. So we can go into this dependencies file, say this one depends on fields, and then in our view, we can go back to our input, and we can actually replace this with our component. So in Volt, components start with a colon, so you'd say, give me the text field component. And then one last thing that we're going to do is instead of creating or using the default page collection, we're actually going to create a new method that sets page new to do to what's called a buffer. And so a buffer is basically, since all of the collections automatically sync, a buffer gives you an instance of it that doesn't sync until you call save on it. So we can say, grab the to-dos and get a buffer. So a buffer is sort of a new instance that will save back when you call save on it. And then when we add the to-do, what we're going to do is actually call save on that new to-do, and then that returns a promise, so we can do then on it, and then we'll call new if that succeeds. So what that gives us, let me do one thing real quick. And so what that gives us is basically, oh, sorry, I did something wrong. This is the problem with live demos. Oh, I know what it is. Okay. We actually need to call it from the index, so it sets up when this gets called whenever this part of the page loads. Okay, so now we get basically these live validating fields where if it doesn't pass the validation, I actually can't save it. So it's not until it passes the validation that I can save, and we get these kind of nice error messages that handle, you know, blur events and things like that for us. And so that kind of shows how the Volt components work. It's kind of nice. You can drop them in, and then they get exposed as tags. Okay, so hopefully that kind of gave you a feel for what it's like to work in Volt. Real quick, I just want to go through a couple of the other things that Volt gives you. Again, I mentioned components. They let you bundle up client code, assets, and server code into gems, and then you can provide them as tags. So we actually have a bunch of components that we've already built. So we have ones for field error messages, pagination, file upload we're working on. That one's not actually done. We have ones for Google Maps, so you can just drop, you know, a couple, like drop the gem in, and then you get a tag for Google Maps that lets you pass things. And you can pass in model collections, and it'll kind of reactively add or remove markers on the map and things like that. And then we have login sign-up templates and things like that. We also have tasks. So in Volt, a lot of times you'll just work with the models kind of directly on the front end, but sometimes you have things that you kind of want to run on the server side. So for example, if I had a ton of to-dos and they were paginated, I might not want to, I wouldn't want to load all of those on the client side, right? So I'd only want to load the ones that are paginated. So a task basically lets you call a method on a class on the front end, and that class doesn't actually load on the front end. It just proxies to the server and then runs on the server, and the method returns a promise that lets you kind of handle if it succeeded or failed. So it's kind of this nice, easy way to call things on the server from the client. And then we have validations and permissions, so that you can kind of say, you know, who can change what and what can people see and things like that. And a lot of this is kind of based around our user model that you can use. So just to recap, you know, again, talking about complexity, Volt's kind of trying, I think, to repack the suitcase, to use that metaphor, and try to find kind of a better way to build web apps. So I think autosync helps a lot with that. It really means that you can write a lot less HTTP and REST APIs. Obviously, you're still using that for loading the initial page, and you may need to write that for third-party data access. But I know, at least for me, in the last several years, I've spent a lot of time just writing REST APIs solely for the front end, my own front end to consume that data. And to me, that seems like a waste. It seems like something we can push into the framework. You get the benefit of writing in one language everywhere. I think components are a big win as far as code reuse, and sort of being able to nest them makes things really nice. You get the benefit of a single framework. So right now, if you're writing a Rails app and an Angular app, you've got to learn two different things, do things totally different ways. And then I think the other big benefit Volt gives you is all of your state ends up centralized in different areas. So that means that you can kind of quickly serialize the entire state of your app. You can say kind of what ends up in the routes and in the URL, and it makes things really clean and easy. You can also store state in controllers and things like that, and it ends up sort of, I think, you're not manually syncing state between different places because the state itself is always just in one place, and the bindings basically make it so that every other place you show that state is dependent on the first place. And then lastly, I didn't get into it much, but we do have a sort of unified router that runs both on the client and the server. So hopefully you can see that what Volt is trying to do. It's an ambitious goal, but I think we're on kind of the first steps, is to take this complexity and kind of bring it back down, so that as web developers we can kind of go back to developing for the entire full stack instead of kind of farming some of that out. If you're interested in getting started with Volt, we've got some video tutorials. We have pretty good docs, I think, for an open source project. And then I'm always around we use what's called Gitter, which is kind of like an IRC, browser-based IRC type chat, but it integrates with Git and things like that. So we use that quite a bit, and there's always someone around that will help you on that. If you didn't follow, if you hadn't seen Volt, I actually hadn't planned to kind of introduce it until a week or two ago, but several months ago, Matt's actually tweeted about it, and so we ended up getting about 50,000 views to the GitHub page in 48 hours. So, and that was long before it was ready, anywhere near production ready. So it's obviously still a work in progress, but I think we're about at the point where you can start building some real apps on it. Some of the things on our roadmap, we want to do more data stores. Right now it's just Mongo, which we're using because it's really popular and easy for us to integrate. We want to do Rails integration. A lot of people have asked to be able to integrate parts of Volt into their existing Rails app. We're almost ready. Actually, I think within the next month we'll have where the views actually render first on the server, and then it sends all of the compiled JavaScript code, and then as soon as that's loaded, it will hook into that. So that'll be really nice for things like search engine indexing and for initial load time, because you won't have to make 2 requests for the data. And then long-term goal, we'd like to do something like Ruby Motion integration, where we're actually sharing probably controllers and models between not only the client and the server, but also mobile apps and things like that. Again, that one's a ways off, but I think it's definitely doable. I wanted to say thanks to all the people who have helped out. These are some of the people from the Gitter room. And then if anyone has questions, feel free. Okay. Any questions? I totally overwhelmed you guys.
I have a question.
Yeah, go ahead.
How much with the E-level? I think framework.
Hey, I'm sorry, it's totally cutting out right now.
Can you hear me here?
Yeah, that's much better. Yeah, sorry.
So my is about just FNS. So there's a lot of state. How well does that play? E-level caching in an application like this.
Okay, so sorry, I actually missed the very first part. So I got the part about caching. Yeah, so Volt tries to, and if I'm answering the wrong question, let me know. Volt tries to, when you make a query, it sort of subscribes to that query. It'll say, hey, give me all this data for this query, and then tell me when any new data changes that would affect this query. And so you'll get, it'll get events saying, this query, there's a new item in here that matches this query. One of the things that it does is it basically holds onto those queries for a second after you're no longer using them, so that if another thing starts using them, so you jump between two pages, it'll keep that open and it'll sort of cache it. When you're doing something like pagination, for example, I didn't show this, but what you actually get is you can use those reactive values. So you could say like bind to the params page attribute, and then whenever the page number changes, it'll rerun the query with the new page number. And so Volt is sort of smart about that. We can obviously improve a lot of that. But on the back end, we sort of we have this is still a work in progress, but we basically parse the queries themselves to figure out which document, when a document is being updated, does it match any of the existing queries out there? That's kind of answering a couple things, but does that kind of answer some of your question, or
Yes.
feel free to do a follow-up. Okay. Yeah, and I think there's actually a lot of opportunity for caching that we're not doing yet. You know, one of the things that once we're rendering on the server first, we can actually send all of the queries with the initial response. So that'll be useful too, I think.
So I have a question.
Okay.
Notice an example. Demo app. This is pretty early on. An example of a fleshed out control that you worked on, at least for yourself, just to see what the structure ends up looking like when you start adding
Hey, I'm really sorry. I actually can't hear you guys when you're talking very well.
Sorry.
No, it's okay. Would you mind typing it in? It's so funny. Like, as soon as you guys start talking, it just totally breaks up. Are you guys able to hear me? Okay, that's funny. That's really interesting. It's funny because I can kind of see you guys, but it's as soon as you start talking, it just like totally breaks up. So the difficulty of doing remote demos. Okay, so the question is, can I show an example of a fleshed out controller or view from your work? Let's see. So yeah, give me 1 sec here. So I actually have a larger project that I'm working on that I am doing partly for a contract, so I don't think I can really show that one. Let's see. So this one's actually online. This is our contacts demo app, so it's sort of a yeah, I guess this isn't really very good either. So I guess I will say in Volt, you don't end up with super large controllers. You tend to break things up. I didn't talk a ton about how the components break things up yet. That's kind of a whole nother presentation, I think. Yeah, to be honest, what I need to do is go back and build a bigger demo app. The thing that I'm working on, I can't really share right now, but it's not. I will say it doesn't end up looking like Rails. You know, you end up having, you don't have, you know, kind of the standard 7 methods. It ends up being a lot more. You know, here's something so that the view can get this data. Here's something like so this one, for example, here's what a query looks like. So so we might have. In this case, we're saying take all of the contacts and then find any of them that match this query as a regex. And so query is a value that's bound to a field in the view. So if anyone hasn't seen, I can just show this up real quick. It's still run. Sorry, 1 second. So in this app, for example, we're doing.
Please share your screen.
Oh yeah, sorry. Sorry about that. So in this app, you can sort of create contacts and save them. This is a really simple app too, so it's not a great example. But you know, one of the things that we're doing is searching. So we have this field that's bound to a query attribute, and so basically in our controller, we have this queried contacts that is a method that gets called here. So we're saying loop through each of the queried contacts, and we basically say, okay, return all that match whatever the query in the text field is. And so we end up where whenever the text field changes, it's going to rerun this query, which is going to update the view. And so I guess to kind of answer your question, you end up with a lot of things like this where it's very short methods, and a lot of the heavy lifting is kind of done by the bindings. And then if you have kind of a ton of data, like a method that's going to change a lot of data, so you'll end up with a task. And so that kind of ends up just being a method call from the controller. Sorry, I know that's not the best answer. I actually, I'll try to do a larger demo app this week so you can kind of see what some of that stuff looks like. Anyway, did that answer your question at all? Oh, sorry.
Sorry, yes. Sorry, yes.
Okay. Yeah, go ahead.
Do you use any other alternative, or do you only have the XAML or YAML or
Do you support any other techniques besides the one that you use?
Any other? Sorry, it's breaking up. Any other data stores? Was that the question? Sorry, guys. Let's see. Any other template syntax? So a lot of people have been asking for HAML. Is that kind of the one? Yeah. So we don't at the moment. There's a guy actually that is going to work on it. So I think it might be a little while, but I think pretty shortly we will. Basically, what our current template language does is compile to little chunks of HTML that are kind of split based on the bindings, and then to Ruby code that we pass to Opal. So it's actually something I could sort of make into a specification, and then anyone could write a parser for it for any other thing if they wanted. I haven't done that yet, but it shouldn't be too hard to do that. So yeah, a lot of people have asked for HAML. So. Any other questions?
I think we're going to say thank you.
Yeah, thank you guys for letting me present. I really appreciate it. Enjoy it. Thanks. Enjoy the rest of the meetup.
Thank you.